Morning, everyone. I'd like to thank everyone for coming. I know it's early in the morning, getting the first session, but don't worry, I'm working on 2 hours of sleep as well, so we're in this together. This morning, we're going to talk about file format fuzzing. Obviously, we'll get into it in a second, so you'll have a much better understanding and background of exactly what it is that we're going to discuss. Who are we? My name is Michael Sutton. I'm the director of iDefense Labs. This is Adam Greene. He's a senior security researcher with iDefense Labs. As you may know, we were acquired last week by VeriSign, so I'm now a proud member of that team as well. What are you going to get out of this presentation? We're going to discuss what file format vulnerabilities are, why they're a concern, why they've become an emerging issue for us, what risks they entail. But the meat of the presentation is to discuss some research that we've done to automate the discovery of those sorts of vulnerabilities. We're going to discuss some tools that we've created to help with automation, and we'll actually release those today. With that, I will turn it over to Adam.
Okay, so there's been a lot of research into fuzzing in general. Most of it's been focused on fuzzing network-based protocols. And really, if you think about it, file format is just the same as a protocol that you would see in network traffic. It's just a standardized means of communication, just like anything else. So when you're fuzzing, of course, you're trying to create non-standard versions of the files that you're dealing with. And you're testing whether the applications are going to be able to gracefully handle malformed files, see if they're going to be able to, catch exceptions, basically just do the right thing in all cases, whether it be, bomb out on a messed up file, try to repair a corrupted file, things like that. And we're interested in just what happens when an application doesn't do this. So obviously the security things, you're looking at buffer overflows and things like that. So if you look at the historical side of it, there's really been a pretty significant increase in the recent years of just the vulnerabilities that we're seeing come out. I mean, here's by no means an exhaustive list. And I mean, if you look at, for anyone who follows all the Microsoft security advisories, the last patch Tuesday, 2 out of the 3 vulnerabilities were actually in file formats. They were image formats. And really, the JPEG GDI plus bug was what started kind of raising our interest in this field, because it was really a big deal. Got a lot of attention, and it was an interesting vulnerability. So if you look at MSO 4041, this was something that actually came through the iDefense Vulnerability Contributor Program. So we worked with Microsoft to get this fixed. And it was really as simple as modifying 4 bytes in the file. The FF pretty much just caused it to do a really long copy of a string onto the stack. So you can see how that would be a problem. Here, if you load it up in Ollie, you'll see EIP is overwritten, and that's fairly trivial to write an exploit for. So think about what's the risk for file format vulnerabilities. Certainly, it's not the same thing as a network daemon having a vulnerability in it where the daemon's always there sitting, waiting, and you can attack it at any time. In this, you're really targeting users, uneducated users, people who have been taught, don't launch an executable, don't trust, batch files, COM files, things like that, but haven't necessarily been taught, don't open an image file. So you're targeting those kinds of people, which really is, mostly everyone who's just an end user. Maybe not everyone in this room, but in general, most people who are using a computer.
I just wanted to point out, somebody was asking about the screens. Unfortunately, we've only got the slides over here because there's some concern. We got to switch some laptops, and we were having some problems. So unfortunately, you're going to have to look at the slides over here, or they're in your book. We haven't actually changed them from the book.
And also, we're looking at default configurations, especially on Windows. Windows is designed to be really convenient. And that leads to, a lot of things can be launched automatically from the web browser. There's ActiveX, of course, and there's even just some things that, Microsoft Internet Explorer will just go ahead and launch and process for you without even asking you. And of course, there's images, which are always going to be rendered in the web browser, whether you want them or not. And looking at like layered security, it's very popular to, have signatures and filters for, network attacks. It's very common to filter email content, things like that, but you're not always filtering things that are just going to be rendered in a web browser. So that's another problem where you can have some sort of targeted owning through like a web browser vulnerability or something like that. And now talking about identifying targets, go back over to Mike.
So an interesting difference in a file format vulnerability is that the vulnerability does not lie in the file itself, whether it's a Word document, a PDF, a JPEG, whatever the case may be. The vulnerability lies within the application which interprets the file. So when you're doing vulnerability research, there's two pieces to the equation when you're searching for a target. Number one, you want to pick a file type, the target, and you're typically going to want to pick something that is commonly trusted, commonly traded. So image file formats fall into that, things like JPEGs, GIFs. I mean, it's only so realistic to block a file format like that. They're on the web. What are you going to do? Block the internet from your users? Things like formatted documents, Word documents, PDFs, rich text format, and then media files, video and audio files. So that's the one side of the equation. You can divide those into both binary and ASCII. The tools that we'll discuss later on sort of address both of those. Binary files are, binary files. We showed you sort of that MS Word vulnerability. That was an issue in a binary file. On the flip side, we've also done some research on ASCII file formats, typically things like XML, INI files, things where you have sort of a listing of name-value pairs. And what we found typically in the file format vulnerabilities on the ASCII side of the house is it's the value in the name-value pair is allocated a specific amount of memory. Give it too much of a value, and it'll overflow, and you get a stack overflow. So we divided the file types into those two targets, binary and ASCII. But then again, there's a second part of the equation. The vulnerability does not lie in the file, it lies in the application. So you also have to select the application that's going to launch that file. And on the Windows side of the house, Windows is a very user-friendly operating system. It's designed so that, you can have a JPEG file and it has a default application that works with it. JPEG, for example, maybe it's Internet Explorer or it's a picture and fax viewer, whatever the case may be. So typically, if you're going to look for a target and you want something that's going to be sort of, higher risk target, you want to target that default application that handles a particular file type. So how do you figure that out? How do you determine which application is associated with a particular file type? There's really two ways within the Windows side of things. Just for going forward, sort of, I've handled the Windows side of the research, and Adam's handled the Unix side. So when we get into the tools, it'll be divided that way as well. So how do you figure it out? Within Explorer, very simple. This actually, it won't tell you everything. We found certain file types where the associations were not actually listed in here, so this is just one way to do it. Just go in Explorer, do Tools, Folder Options. In this case, we're looking at a JPEG. You drill down, go into the Advanced Settings. Windows allows you to have separate actions for a particular file. In this case, Open and Print To. Drill down into that. And what we're looking for here is, you'll see it says application used to perform action. Think of this as a command line, how to launch this file in this application. And that's really important for us because we're trying to build tools to automate continuously launching and killing this application. So we need that information because it'll tell you the application to launch it, any flags that may have to be passed to it, and the path to the actual file. And Windows can actually be really picky. Sometimes certain things will be enclosed in quotes or won't be enclosed in quotes. And we found that you have to stick to what you find here. So as a general rule of thumb, if you copy that line, that's what you want for automation purposes. Other place you can get that kind of information is directly from the registry editor. Just file up like regedit, and same idea. This actually is a case. It's one of the original vulnerabilities we found using our tools. It was in a Microsoft Interactive Training. And so that file association actually wasn't listed in Explorer. I don't know why some things aren't, but we had to look in the registry to actually find it. And in this case, there's like a -f flag, so that was important. And the file, the %1 was enclosed in quotes, so that again was important because without that it wouldn't launch properly. I'll give it back to Adam for the Linux side of the house.
Okay, so finding targets on Linux is a little bit different than Windows because you're not necessarily targeting point-and-click things that are going to open. The most interesting target that, in my opinion, on Linux is some of the antivirus products, be it open source ones like Clam AV, or a lot of the commercial AV companies actually have engines for Linux. And I found them particularly interesting because you can actually use one of our fuzzers locally and hammer away at it, and if you find a vulnerability, you can bet not only that it's possible that all deployed versions of that engine, including the Windows versions or whatever other versions are available, will be vulnerable, but also that it's possible that it could be actually a remote vulnerability if it's the same engine that they use for their gateway scanning. If they have that sitting out there filtering email, then you're able to trigger that remotely. So that was something that I found interesting, and I think for any of you who, I believe Neil Mehta did and Alex Wheeler did I think they focused more on reverse engineering, but they focused on antivirus engines. Media players like Real Player is pretty popular, and that's another thing. Both Real Player and Adobe Acrobat, if you're targeting the Linux versions of those, you usually have like about a 50-50 chance if you find a vulnerability in the Linux version that it'll also be in the Windows version. Some of the code is the same, some of it isn't. So sometimes you get lucky, sometimes you don't. Web browsers, of course, image formats and stuff. There's so many web browsers out there. Mozilla, Firefox, Netscape, Opera, all those. So those can make for interesting targets. Excuse me. All right, so when you're creating files, you look at what types of fields you typically find in a file. Of course, you have integers in many forms, signed and unsigned bytes, words, dwords. And then when you're looking at ASCII, aside from just plain text ASCII, when you're looking at ASCII within a binary file, you'll find C-style strings, just null-terminated ASCII strings. Things like XDR, length tagged strings, which is basically just a string, and then somewhere either before it or after it, it'll have a length tag, which will just describe the length of that string. Like for example, in Sun RPC, it's just the ASCII string. It'll be padded out so that it's a multiple of 4 bytes, and then it'll have a 4-byte big endian length prepended to it. And you'll see that a lot in a lot of the Microsoft Office formats. Not that exact thing. It's probably little endian. And there's also 1-byte lengths, 2-byte lengths, things like that. You'll notice it. It's usually fairly easy to spot. So when you're going to be messing with these values, you have to pick interesting values, obviously. So some interesting values to choose. Negative numbers, large numbers, small values. Like small values, I believe 1 or 2 would trigger the GDI plus vulnerability because it did something like a malloc of the original value, so for example 1, and then a subtract 2, so it would wrap around and then copy that much into that small malloc buffer. Then ASCII strings are usually pretty easy to choose interesting values for. Large strings and empty strings for just truly simple ASCII strings. And also if you're looking at length tags, you want to try lengths that don't accurately describe the string. Maybe a short length tag with a long string or vice versa. Or you can just have an accurate length tag, but just a really long length tag and string. And that's actually pretty effective. There's been a whole bunch of vulnerabilities. And those are usually stack overflows, which means they're usually pretty easy to do reliably. And of course, strings with format specifiers for format string vulnerabilities. And why are those so interesting? I just kind of sum that up in a nutshell, but obviously decrementing small integers can cause them to wrap around and you have problems there. Multiplying, adding, and incrementing, same deal. And just the inconsistent methods for determining the size can just cause a lot of problems depending on how the logic is done internally in the program. And format string stuff is pretty obvious. So I'll go back to Mike here. He'll discuss some of the methods that we looked at.
So I always tend to think of vulnerability research as you have 2 primary approaches to being able to do it. What I refer to as the outside in, that's where you're doing something like fuzzing, You don't do a lot of research on the actual file in this case. You're throwing everything but the kitchen sink at it. It's not a surgical way of doing it, not a scientific way of doing it, but it works. The other side of the house is what I call the inside-out method. That's the reverse engineering. Much more surgical, requires a lot more work and research. And again, it's just two different ways of doing it. There's not a right and a wrong way. We feel that file format vulnerability discovery really lends itself to brute force fuzzing, or what we'll get into we call intelligent fuzzing, just a smarter way of doing it. So fortunately, it lends itself to that. And the reason is because you can automate the discovery. So, start something, walk away, and then come back and see what it's found. What are some of the advantages of pure brute force fuzzing? And when we say brute force, we mean just pure bit flipping. So take an entire file, flip every bit, give it every combination in every location in that file, launch it, execute it, and see what happens. Watch for exceptions. That's pure brute force fuzzing. What's the advantage of that? You don't need to know anything about that file format. You don't have to do any research. I can take a JPEG and just flip every bit in that file, launch it in Explorer, and see what happens. So long as you can automate the execution of the application, and more importantly, the detection of any exceptions that will occur, that lends itself very well to a brute force approach. And that's why I walked through that section where I was saying this is how you figure out what application launches what file with what flags in what way, because you need that information, at least on the Windows side of the house. What's the downside to a pure brute force approach? One of the things we ran into immediately was we found file formats that had dependent values throughout. A good example would be like a PNG, which is an image file format. It has actual checksums throughout, and the reason for that is, it wants to identify malformed files, not necessarily because somebody's doing something malicious, but, something gets messed up in transmittal. And so that signals to the application that there's a problem, and so it'll exit before. And so the thing that we found is when file formats have a dependent value, we need to account for that. We can't just change something without changing the dependent values, because if we don't, we'll never get to the location where a vulnerability will occur, because the application will just kick it out early on. So brute force fuzzing won't work in that situation. And we'll talk about intelligent fuzzing in a sec. Another downside is there's many false positives. I mean, the tools that we'll present, they both handle brute forcing and intelligent fuzzing. It's not the end game, though. These aren't tools where you just push a button, you walk away, you come back, and there's a vulnerability that's all written up and nice, and you mail it off to Microsoft, and everybody's happy. It will let you know where an exception occurs, but then it's up to you as a researcher to determine, is this an exception that's worthy of further research to see if it can actually be exploited and presents a risk to us. I said intelligent fuzzing. All we mean by intelligent fuzzing, I mean, it's not an industry term, it's just something that we've used when we were discussing it. We just mean not a pure brute force. Find interesting parts of the file. A typical file format has a header and a data portion. Within that header, there's a bunch of name value pairs. So identifying those, fuzzing those sections only. Fuzzing things that are interesting, like if there's a portion in the header that identifies a size within the data, that's a good target to go after, but you have to know where it is. So how do you figure that out? Well, go to the old-fashioned way, do some research. If you're dealing with an open file format, there's plenty of resources out there. There are standards groups, there are websites that give plenty of information. This is just a listing of some basic URLs to get you started. What do you do if you have a proprietary file format? There's still plenty of information out there. If you choose to do some fuzzing on a proprietary file format, I'd encourage you, don't start from scratch, because chances are if you want to reverse engineer a proprietary protocol, somebody's done it before you. As with most security research, Google is your friend. Go out there, do some searches. Chances are somebody else has some information. A simple thing that we found was helpful is just basic file diffing. You have a proprietary format, you don't know anything about it. Take a bunch of different files that are of the same type and diff them, and especially if they have fixed header lengths, you'll be able to tell pretty clearly, which portion is header versus which portion is data. You may, again, if they have fixed lengths within the header. You may even be able to see, you know, where's the name, where's the value, and the name-value pairs. So it's simple, but it's a helpful way to get started. And the last two URLs we have there are really good collections of just a ton of specs on file formats, whether they're open or proprietary. Basically, you go in, you look for the extension, and it'll have an alphabetical listing of stuff. And it could be anything from a standard that was released and is official to just what some guy did on his own to figure out proprietary format. So what are the good and bad things of what I'm referring to as intelligent fuzzing? You can target individual portions of the file. So, you know, it's going to be more efficient. You can target those so-called interesting fields. I gave an example. You know, there may be a portion in the header that describes a size. You know, that's always a good place to start looking for a buffer overflow. When you have those situations of dependent values, like a CRC 32 checksum, you can account for that so that when you're fuzzing, say, a portion in the data, you know, you can accurately update that checksum early on. One of the tools that Adam built, FileSpike, accounts for that, and so that's an approach to doing that. We'll get into the demos in a minute. What's the downside? It's more work. You know, you have to do some research. You have to figure out what the file formats are. Some of these file formats are very complex. That's why these vulnerabilities exist, because people are building applications to account for a specification that's very complex, and it has a lot of information in it, and they don't account for everything. So it's more work. You're going to need to build, you know, multiple script files to account for all of the different variations, so it's hard to get complete coverage, but you're going to get less false positives.
All right, so we've discussed all the basic methods and really all the interesting values, things like that. When you're actually implementing a fuzzer of this nature, like it's not like a network daemon where you can send it some garbage, disconnect, send it some more garbage, disconnect, start new connections like that. You're going to have to be continually executing the program because it's just an application. So it's incapable of restarting itself. So you can either, you know, if you're doing this manually, you can use task kill in Windows or just kill in Unix. Or if you're using like a GUI and you want to use like one of the API calls, you can do the same thing. Or if you chose to do like a specialized browser fuzzing, for anyone who's seen Mangle Me by LCamTough, it uses this method. It specifically is designed just to fuzz browsers, and what it'll do, it's basically just a CGI program that'll dynamically spit out either, in Mangle Me's case, bad HTML, but you could do it with just about anything. You could do ActiveX controls, images and stuff, but it'll dynamically spit out malformed stuff like that with a meta refresh tag, which will just tell it to refresh to that CGI again in, you know, X seconds. And then, of course, since it's dynamic, the next time it refreshes, it'll spit out something different. And then you obviously be able to figure out when the browser crashes because you'll stop getting requests. And so in that case, you don't need to worry about after X seconds, I need to kill this application and start a new one. We didn't really focus on that too much, but it's definitely an interesting approach. Monitoring for exceptions is really the bulk of the work that we did in our fuzzers. Because it's the most important thing, really. You can have function hooking to catch exceptions and stuff. In my case, I just used ptrace, which is available on pretty much every Unix, although my tool isn't designed for anything other than Linux, and it won't run, so I wouldn't try that. You can monitor standard output and error if you want. Really, the cleanest method is the first two that we mentioned. These are just alternate methods. You know, looking at error logs, of course, if the application crashes, that's notable, and even just looking at the return value. But of course, with those methods, you're not going to get any real information. You're not going to be able to dump register state, things like that. So we're looking at a couple of vulnerabilities. This is just for anyone who's heard of these vulnerabilities and didn't know what they were, like what category they fell into. Stack overflows, that's one that we discovered with our tool. The Microsoft Interactive Training Buffer Overflow. That was just an ASCII-based stack overflow. Heap overflows, this was a heap-based integer overflow that we're working with the vendor to get fixed right now. And GNU bin utils readelf. Not a terribly serious vulnerability, but bin utils made for a good test suite. They have more integer overflows than OpenBSD. Of course, the JPEG issue got a lot of press, so I think everybody knows what that was. That was just an integer overflow. And there was actually a format string vulnerability in Adobe Acrobat Reader a little while back. So all these bugs are out there, and they're all over the place. So here's the tools that we designed. I had two that I did, spike file and not spike file. Spike file is based on spike. Not spike file is not based on spike. And then Michael creatively named his tool File Fuzz.
Yeah, there's things we're good at and things we're not good at. And naming applications, not our... Maybe now that we're part of Verison, I can hire somebody to come up with names for tools. So as I mentioned earlier, the way we kind of split up the research is Adam focused on the Linux side of the house because that's where his strengths were, and I focused on the Windows side of the house. So on the Windows side, the way I chose to approach it is do more of a pure brute force file format fuzzer with some intelligent capabilities within it. It's GUI based. You know, one nice thing of programming in Windows is that it's pretty much as easy to make a graphical application as it is to make a console-based application. The programming was done mostly in C# on the .NET platform, so that's a requirement for running it. One thing I should note is all the three tools that we're discussing, they're being released today. All of our stuff we release open source, so I strongly encourage you, give us feedback, let us know what works, what doesn't work, and especially, if you guys want to participate and build it, add functionality, give it back to us. I'll gladly give you credit in the changelog and re-release it. I mean, that's what it's all about. So, what does File Fuzz need? Let me just actually walk through it. So, as I said, simple GUI-based application. Hopefully you guys can see it. I realize some of the writing is a little bit small, so I'll try to explain. So, I've split it into, as I talked about, you need to find a file to target, and then you need to be able to launch it and monitor for exceptions. So, it's kind of a two-phase approach. Create the files that you want to fuzz, and then execute the applications to launch those created files. I have a number of canned applications, or canned audits, I'll call them, so that you can just start right from scratch, but you can do any file type that you want. So in here, there's just various things, like there's a PDF which is launched by Adobe Acrobat, which the file name is acroread32. Now, anything that's in that drop-down list is actually behind the scenes is an XML file, and that was done on purpose so that anybody can add their own audits, and it's not hard-coded into the application. All you have to do, the XML file format's very basic. All you have to do is just add a new audit, and it'll show up in the drop-down menu. So the idea is, pick the file type. So in this case, I'll pick WMF, which is Windows Metafile. Is that right? It's a vector-based graphic format that Windows has, and it's launched by I think it's the Windows Picture and Fax Viewer, which is actually a DLL. It's not an exe. So anyway, pick the file that you want to pick a target file. So I just have included with the application a test WMF file. Where do you want to dump the stuff? What do you want to actually fuzz? So in this case, I'll say I want 4 bytes of FFFF, and I want to do it either throughout the entire application, all bytes. So I'm just going to go 4 bytes overwriting FFFF throughout the whole thing. That is pure brute force fuzzing. If it's a really big file, you probably don't want to do the whole thing because it's going to take some time. So you might want to do a range, and more than likely the vulnerabilities will occur in the header section. So you want to do the first chunk of bytes. One thing I found is that the first 2 options give you the breadth, so you can just brute force fuzz all different areas of the file format and monitor for exceptions, and then you'll find one. Let's say you find at byte 100 there was some sort of an exception, but you don't know if you have any if the user has any control over it. Like, I don't know if my FFFF ever actually gets into the disassembly, like I can actually control something. So then I added the depth option so that I can, at byte number 100, do a whole bunch of different byte values, not just FFFF. And then when I watch the exceptions and I watch the values that are showing up in the registers in memory, if they're always the same, I probably don't have control over it. If I see a whole bunch of different exceptions or different values in the registers, that gives me an indication that probably I do have control over it. The match option, that's geared more toward ASCII file formats. The first three are typically going to be used on binary file formats. The match file format just allows me to target a binary. Like we mentioned that we found a vulnerability in Microsoft Interactive Training, which is an application that comes on OEM installations of the Windows operating system. Dell computers, for example, have it. And it's just a really simple, I think it was an INI file, is that right? Or an XML file? I don't remember. But anyway, just a simple ASCII file where it's, name equals value. And so by just fuzzing the value side of the house, in this case, I'm saying replace that with all A's, with 100 A's, and then keep incrementing it. So it's 100 A's, 200 A's, 300 A's, all the way up to 1,000. And you'll find Stack Overflows that way. Anyway, so you're just picking your target, figuring out how you want to do it. I'll just say all bytes for this, create my files. So it's just going to, as I say, it's doing every byte. So in this case, it's a small file. So I don't know, so it made 296 files. And then on the other side, now that you've created your files that you want, your fuzzed files that you want to launch, now you have to launch them, and you want to be continually launching them, killing it, and then monitoring for exceptions. And we're just using the Windows API to look for those exceptions. I'll do this in a VMware environment, just in case something crashes. I'm not going to bring down our PowerPoint presentation, but so it's really simple stuff. You're creating those files and then just continually launching it, killing it, launching it, killing it, and you're saying, are there any exceptions? This WMF file format, it's hard to see in VMware. It's kind of an interesting one because sometimes the file will fail, so you won't actually see it, but every once in a while the drawing gets rendered, and it's just an interesting one to watch because it's a vector file format, so I'm fuzzing things, and so it's actually changing what the image is. So it's supposed to be a triangle. The one you just saw was what it really looks like, but every once in a while you'll see this warped, like when I started doing it, it started as a triangle, and then it was a blue triangle, then it was a green triangle, then it was upside down, then it was warped, and so just, I don't know, it's interesting to watch. Like you can actually see how your changes are impacting the file, and then you're looking for exceptions. Like in this case, obviously I knew I was going to get an exception on file, and I know you guys can't read this, but I'll read it. On file 260, there was an access violation. Is this interesting? Is it not? In this case, probably not. It's just, doing a move, zero extend. But so the things that I chose to capture is I want to see when there's an exception, and it's not enough just to watch for an application to crash because, Windows has all this graceful exception handling, so you may never see it if you're just looking for something physical. So you want to monitor for exceptions at a lower level. And the things that I've captured are, what was the operation in the disassembly that occurred at that place so that I can see if it's interesting, what were the register values. Things that I may add to this in future is, a snapshot of the top of the stack. What did that look like? Maybe instructions before and after where the actual exception occurred. And so this way, you can run the fuzzing, let it run all night. Fuzz like 10,000 files, wake up in the morning, there's 10 exceptions there. You can quickly look at it and say, are any of these worthy of deeper research? And now Adam will discuss the Linux-based tools that he developed.
Okay, the first tool, which I'm actually not demoing today, I chose to just demo the other one, but it'll be up on the website if you're interested. It's an adaptation of Immunity's Spike, which for anyone who's never heard of it, it's just a protocol, like block-based fuzzer that was designed basically for TCP/IP networks. So it's been modified, obviously, so that it can target files, and I added a way for it to execute and monitor for any exceptions, basically just catching signals and stuff using ptrace. It'll do multiple processes, so you can have 5 applications processing 5 different files at once, which speeds things up a little bit. I added CRC32 over blocks. Spike supported things like lengths over blocks, so I added CRC32 just to see how easy it would be. And it takes Spike scripts as input, so if you speak Spike, then you'll have no problem. And this was used to discover a real player vulnerability that we're working with real networks to get fixed right now. And then there's not Spike file, which is similar to Michael's fuzzer without the fancy GUI. Requires a valid file as like a baseline, and it'll mess with it from there. It has all the same features as Spike file. And this was used to discover an integer overflow in bin utils, which is what I'll demo. Not because it's a serious vulnerability. I don't think I'll lose my job or get sued for showing it to you. But it demonstrates my progress bar. That's really the only reason I like to demo it.
He's really proud of that. He thinks that makes up for a GUI.
Can you hit enter when I
Sure.
tell you to? Not yet, though.
We only have 10 minutes left.
For anybody on that side of the room, I apologize, but there's not really much to this. The dash B just means binary fuzzing. The dash K means it's not going to kill the application because readelf exits usually on an error or on success, so you don't need to do that. Dash M10 means it's going to have 10 processes at once. Dash O, fuzzy uname, is just going to be the file it outputs. And uname is just a file that I copied from an SGI IRIX install. It's just a plain MIPS binary. And then you just tell it what to do, so you can hit enter. And you'll see it'll fuzz through it. Since it's such it's not a very complex program, readelf, so you can do a lot really fast. You can see there's already 30 crashes or whatever. If you let it run, there's something like 30,000 crashes or something like that. But what it'll do is it'll dump a text file for every unique faulting address. So like every EIP has its own text file. So you see there's a whole bunch. Just the one that I would show you. I mean, some of these are exploitable. A lot of them aren't. There's just quick notes on the one that I mentioned. EIP is actually that hex value, which if you print it out, it's G_AR, which is a string from the binary. So obviously if you have EIP with a string that's in the binary, that's obviously going to be exploitable. And if you just go to the source, because it's open source, it's just an integer multiplication heap overflow. It's something like that, where you're reading a value from the file, mallocing it with the multiply, and then it wraps around and you've got a problem in a loop. So that's basically all there is to that one.
So these tools are and will be on our website, labs.idefense.com. That's where we have the open source stuff. Just go in the software section. As of right now, the file fuzz, the Windows-based one, is the only one up there. We will put the others up in the next couple hours, working on 2 hours sleep. We can only move so quickly, so as soon as we can figure out the SCP client, we'll get the others up. Adam? There's like 2 or 3 slides left, so we got to blow through them.
All right. So here's just some of the zero-day vulnerabilities that we found while we were testing. The Microsoft Interactive Training one we mentioned, that's already fixed now. We were with Microsoft on that one. The real player one I mentioned, which is the format string bug, and that heap overflow that I just showed you. So future trends and predictions, we're thinking in terms of attack, there's going to be more tools. There's going to be probably an increase in the rate of discovery because of that. There's a lot of simple methods you can use to find these types of bugs. As far as defense, you're going to probably see more aggressive like content filtering. Probably something in the content filtering, maybe that will just detect that it's a malformed file and just drop it completely. And that's about that. Any questions?
So we have some T-shirts to give out if you have some questions. And after the questions, if you want to come up and just grab one, I think we have quite a few. Yeah, go ahead.
Yep.
There's one in the middle here, yeah.
Yeah, would it be beneficial to run this type of tool against in-house built applications? Or?
Yeah, absolutely. These don't have to just be used for evil purposes. They can be used for good. I hope they will be. And especially if you're building an application that is creating a new file type that's specifically by default associated with that application. Especially in the Windows world. Like when I did my testing, those are the sorts of things I targeted because, they're not as likely to have been looked at as like a .doc file, which everybody has access to. I targeted a lot of things that were a particular vendor created a particular file type and associated it with their own application. So absolutely, I would encourage that. Yeah?
Do you pursue any fuzzing on database file types?
I don't think we did. Like, give me an example of a particular file type. Just like binary formats and stuff. Sure. No, I don't think we did, but absolutely.
To tell you the truth, like most of the stuff that we found wasn't like really looking for vulnerabilities. It was mostly just kind of like our test suite. So it's like stuff that we happened to find. We really haven't had that much time to actually use our tools per se.
Yeah, like I really do think this is a low-hanging fruit area of vulnerability research because we really weren't working that hard to find vulnerabilities. We were working hard to build tools. And as Adam said, it was just in testing those tools, we wanted to validate our theory that this was real, and it is. More questions? Oh, actually, hey, I should be giving out T-shirts. Sorry.
Go ahead.
Who asked questions? Just one way back there.
Sure. Yeah. Basically.
Who else asked a question? What?
Basically, like the first thing you look at, obviously, is like the faulting instruction. I mean, sometimes you'll see, it's a null pointer, but you really want to look at it anyway. Most cases in this, because it really is just such dumb fuzzing that it could be a null pointer in one case, but if you fix it up a little bit, it won't be. So really, you just have to, once you get the exceptions, you just kind of look at them and you basically just have to go over them manually. So. And I mean, some things are really easy to recognize if you have the faulting instruction in the register state. Like format strings are usually pretty easy to recognize. Writing off the end of a heap or reading off the end of the heap is usually pretty easy to recognize. But aside from that, you usually have to do some manual work.
Dude, this is my T-shirt, like from the room. You like included it in the file. You almost got my dirty T-shirt. Any other questions? We're going to stick around for a while. Sorry, go right ahead.
Any thoughts about automating analysis of node file formats?
We've thought about it, definitely. It's an interesting field. We didn't do any research into it, but yeah, it's definitely something interesting that I'd like to look into.
Like I totally agree because, as I say, like the only thing that we looked into on the intelligence side was that you doing manual research to figure it out. But it would be great if you could get to the point where it knows where a dependent value is, and it automatically can do the CRC32 checksum and stuff like that. That would definitely accelerate the research. Go ahead.
Yeah, do you have any idea how to avoid antivirus detection using Firefox?
Yeah, I've noticed that a lot. Like if you start with the baseline of just a virus-infected file and run it through, and if you're not looking at crashes, you're just looking at the return value if it returns clean. Yep, absolutely.
Just like give them out to people. Thanks a lot, guys. Appreciate it.